HDFS architecture and components. HDFS is a high availability architecture. Broadly, HDFS has a master-slave architecture. So how does it work? In a typical HA cluster, two or more separate machines are configured as name nodes. At any point in time, exactly one of the name nodes is in an active state, and all the others are in a standby state. The active name node is responsible for all client operations in the cluster, while the standby is simply acting as a slave, maintaining enough state to provide a fast failover if necessary. The master node, that is the name node, ensures that the data required for the operation is loaded and segregated into chunks of data blocks in slave nodes as data nodes. A data node serves read or write requests. It also creates, deletes, and replicates blocks based on the instructions from the name node. The standby name node and the active name node keep in sync with each other through shared edit logs or metadata. The active name node updates the edit logs, which is the metadata information about the storage. This is done with namespace modifications like block locations, the status of the name node, and so on. The standby node reads the changes made to the edit logs and applies it to its own namespace in a consistent manner. In the event of a failover, the standby will ensure that it has read all the edits before promoting itself to the active state. Note that this is a manual failover process which has to be performed by an admin. For an automatic failover, we will need to utilize services of Apache Zookeeper, which maintains small amounts of coordination data. The Zookeeper Failover Controller, or ZKFC, keeps an open session with the active name node by periodically pinging it with a health check command. If the node has crashed, frozen, or otherwise entered an unhealthy state, the health monitor will mark it as unhealthy and elect a new name node.